Hello, everybody. My name's Phil Lamar, and I would like to welcome you to NASA's Ask the Astronomers Live, the show that gives you the chance to ask real, live astronomers your own questions as I talk to them about some of the most amazing things in our universe. Like today's topic. Today we are talking about Oumuamua, space rock or alien tech. For those of you who don't know, like me, that means we're going to be talking about an example of an interstellar object passing through our solar system and the controversy and questions that raised. Now, for those of you that are joining us live on Facebook or YouTube, please make sure you say hello in the chat and definitely send us your questions. This topic is going to raise a lot of questions so that we can answer them for you and teach you how to pronounce Oumuamua. Also, make sure to visit our website at universeunplugged.org, where you can watch all sorts of fun astronomy videos and find out about other upcoming shows. Now, everybody out there, about yourself and where you work, and especially where you live.
Kia ora koutou, folks. I'm from over here in Aotearoa, New Zealand. I'm an astronomer at the University of Canterbury, and I work on trying to understand the questions like, what's in our solar system? How did it come to be? And how does the history of our solar system relate to the history of other planetary systems all across the galaxy? It's a lot of fun. I like using big telescopes, and I like trying to figure out these really interesting questions, including interstellar objects.
Oh my gosh, that is such a CBS TV show waiting to happen. Hi, Joe.
Hey.
Now, Joe, I want you to tell everybody about yourself, but don't repeat what Michelle said, because I know you're not in New Zealand.
I'm not in New Zealand, no. I'm a solar system scientist at IPAC at Caltech, and I use the heat that's emitted by small bodies in our solar system, like asteroids and comets, to track where they're moving and figure out how big they are and what they're made of. And so to do that, we use a space telescope called NEOO. And so this is an Earth orbit constantly surveying, looking for these thermal signatures of these objects moving across the dark, cold background of space. And so we use this to basically get a handle of how many of these objects are out there, how big they are, what color they are, how reflective they are, all to help us figure out, are they going to hit us? And if so, what would the consequences be? And so we want to try and make sure that this isn't a problem for us going forward.
Ah, okay. So basically, Joe, your department is the anti-Michael Bay movie department.
Exactly.
Okay, good.
Fewer lens flares. Many lens flares, though.
Yeah.
Actually, I think lens flares would mess up the telescope, wouldn't they?
It's one of the things you get pretty used to going, oh yeah, that's what a lens flare looks like on an astronomical image.
Yep, we see them all the time.
It's like, oh, I thought that was another solar system, but it's just a lens flare.
Yeah, right. There was one time we found something at 500 astronomical units. Nope, lens flare.
Not a lens flare. Okay, well, let's get to our really interesting topic today. This strange interstellar object named Oumuamua, or I'm still working on it. I'm getting there. Hopefully by the end of the show, I'll get the pronunciation right. Now, this has created a stir in some circles over what exactly the interstellar object is, right? But why don't we start with something that's not a question, and that's the idea that it came from somewhere beyond our solar system into our solar system. Can you guys talk to us a little bit about how Oumuamua was discovered and where it's from and all the other questions? Michelle?
So my involvement in this, so this was in 2017, right? And I was working in Northern Ireland at that time in the city of Belfast. And I'd got up about 6 in the morning to go for a run before, getting on with the day. And I flipped open my email just to have a quick check. And one of the things that always comes in at that time zone was the announcements from the International Astronomical Union's My Planet Center, which is this clearinghouse of where discoveries made by astronomers all around the world of small worlds in our solar system, tiny little things, asteroids, comets, those all get sent to the My Planet Center, and it sends out the notifications of the new ones. And you get maybe somewhere between 5 and 15 a day generally. And one of these was potential interstellar object. And for me, that was like, oh my gosh, this is this thing that we've been waiting for decades. There's like some papers in the literature going, eventually we'll see interstellar objects, but this is a potential interstellar object. So I went, cool. And what did I do? I went on Twitter, like you do, and I went, hey, look, cool, new announcement from the Minor Planet Center. And then I went off and went round the park and went for my run and went, okay, I'll figure this out when I get back, and have had some breakfast. But Joe, you were over, you saw this tweet, eh?
Yeah, so, early morning Northern Ireland was late evening here in California, and I actually was at the Palomar 5-meter telescope that night for a totally different observing run. I was scheduled to take spectra of some asteroids I was interested in, and so I just started a spectrum, and so it takes a 15-minute run sequence, so I do what you do, and you flip over to social media, and I'm looking through, and I see, oh, Michelle said interstellar object. And I pulled up the coordinates, and it's in the northern hemisphere, and it's just bright enough to observe. And so I scrapped my plan for the night and switched over and pointed the telescope at this brand new thing that may or may not be interstellar to see what we could learn about it.
Oh, wow.
Yeah, and your data came in, and you were figuring out how bright it was and like what the surface was going to be like based on how it reflects sunlight, and that would give us some idea of how it relates to the other small worlds we have in our solar system, the asteroids, the comets, the things I care about like trans-Neptunian objects, these little worlds out beyond Neptune. Just, is it similar? Is it different?
Exactly.
And yeah, I remember sitting there like writing. One of my other colleagues, Meg Schwam, said, hey, why don't we point Gemini Observatory at it? And I remember sitting there like a day or so later, writing this proposal going, okay, Joe got this bit of data. Okay, what could we say about it? It was like Gemini North, and then swinging this big telescope round once they said, hey, yeah, you can use it for this, and seeing what it was made of. It was hectic and exciting.
Yeah, really especially because when we discovered it, it was on its way out. And so it was getting fainter every day, dramatically fainter. And so I was just able to pick it up with a 5-meter telescope after it was discovered with spectra, which means that to see it a couple days later, you needed an even bigger telescope. And so every day you wait.
Image one, please.
Yeah, so there we go. So this is what it would look like if you were sitting at the telescope taking a series of pictures. And if you add them together, you'd see the stars make a trail, and that little dot is Oumuamua. But it's going away from us. It's getting fainter. And so if it takes you 3 days to write a proposal to get a telescope to get the time to look at it with the spectrum, it's already gotten fainter and fainter. So the faster you can get on these, the better it is.
Wow. That's really fascinating. I mean, I feel like most of the things we talk about on this show are happening millions of light years away. It's rare that I've heard about something with this much immediacy involved. It's like, quick, turn the telescope.
Yeah, because this thing was moving. So if you want to look at like how it was moving through the solar system, could we have trajectory animation, please?
So you'll see it come in here, and it was discovered there, like just as it passed the Earth on the way out. And so you can see it's getting farther and farther very quickly.
Huh. How do we know it came from outside the solar system?
Michelle,
so
you want that?
one of the things is just the speed with which it was coming. So things that are going around the sun, what we call bound to the sun by the sun's gravity, they can only travel so fast. Otherwise, the sun doesn't hang on to them anymore, and they fly off. So this thing was just going way too fast. It wasn't on an orbit or on a trajectory that could be bound to the sun.
Right. It came in from infinity with some speed and did a quick pass around the sun and went out with the same speed. And so we know it couldn't have come from our solar system because it was heading towards us quickly before it ever felt the gravity of the sun.
Got it. Right. Something couldn't have come that fast if it was already in the solar system. Right. Wow.
Exactly.
And this passed through. How long did it take? Or I mean, you said it was discovered as it was passing the Earth. Were you guys able to figure out how long it took for it to pass through our solar system, in and out?
Well, I mean, it's still going through our solar system. It's just on the way. It's past Jupiter, right? Okay. So it's still here. It's just very, very faint. We can't see it anymore. None of our telescopes, none of our spacecraft have a chance of seeing it. And it's moving so fast, we don't have a chance of catching up to it. without some extreme measures.
Could we have image 3, please? This gives you an idea of just how long it was that we could actually see it with the ground-based biggest telescopes in the world.
Yeah.
So if you look at the bottom along there, the time in universal time, that's days, right? So 1 day, 2 day, 3 day. Yeah, we could get all the astronomers around the world working with these different telescopes together. We got maybe 10 good days of high quality, really precise measurements of how bright this thing was, and then it got too faint. And then you could just see it with Hubble Space Telescope and Spitzer Space Telescope.
Yeah, and what's interesting about this plot is you can see that it starts out at the top, which is brighter, and it drops to those little troughs there. That's where it's getting significantly fainter. And that's like a factor of 25 fainter right there that we're looking at. And so it was not easy to see, even when it was close enough that it was theoretically bright enough, it was flashing on and off to some of our telescopes. I actually ran into that when I was taking my spectra. We didn't know that it had this light curve, that the brightness was changing like this. And so I was looking at it for an hour, I saw it, and then it vanished for an hour. And I was about to give up and it came back. And I had no idea what was going on and why I lost an hour. I thought maybe a cloud came through, but it turns out, looking back now, it actually was, it dropped fainter and it vanished from our sight. So this is why it was even harder to study.
Interesting.
So yeah, this was really challenging. And one of the fun things is this is what we know about the object. This is what we could measure. And so from that it changes in brightness, it gets brighter and fainter. We can infer things about what it's shaped like. So something that's got a shape to it is going to reflect more light when it's side onto you and less light when it's edge onto you, right? Yeah. So you can make a shape model of that. And
image 2 would show that. Yeah.
So this was like what people came up with as an initial shape model to make that change in brightness. So this was the one you might have seen from like the first year or two, but people ended up there are multiple shapes you can fit to that bright and dim and light. And so if we go to image 5, that's more what the shape kind of evolved to as people did more science and tried to work out what's going to be a better shape that fits those measurements that we have.
Ah, okay.
Right. And so it's this flattened pancake that if you look at it edge on, it vanishes. You look at it face on, it gets brighter, reflects more light to us.
I see.
Yeah.
Well, that first image sort of speaks to my next question, which there were some stories about people coming up with the idea that this wasn't just a rock, but some kind of alien spacecraft. I mean, that first image was, the shape of a Galactica battle star. So
it's about the size of a skyscraper as well, just for good
right. Yeah.
Is it the shape? Why did people, jump to these sort of weird conclusions that this might be some alien spacecraft or something other than just trying to get clicks?
Right. Well, it was totally weird, right? As Michelle mentioned, we'd been expecting to see something like this for a while, but we always thought it would be a comet because our solar system kicked out a bunch of proto-comets as Jupiter was forming. And so we thought, okay, it'd be icy, it would look exactly like a comet. Instead, we saw this thing that wasn't a comet. It wasn't active, right? We didn't see a big tail like you can see with comets in the sky. But it also was very elongated, and we don't see things this shape in our solar system very often. So you have something that would be incredibly rare if you found it in our solar system, coming from somewhere where we don't expect to see things, rocky objects being sent our way. And so this is how, if you don't really know what it is, and it's totally outside what you expect, you start looking for other possible explanations. And, one of them always is aliens. It's very hard to prove that. And it's especially hard when Oumuamua left and we can't get any more data. So you can come up with 1,000 crazy theories, and as long as they fit the data we have in hand, it still works. We can't get any evidence to prove or disprove anything after that.
There you go.
Yeah,
right.
I think aliens came up on day 2, as I remember. Like, it wasn't 2 years later. It was day 2 we had aliens. And then aliens got ruled out because it didn't fit the light curve very well.
Right.
Yeah.
That's amazing. Right. So this was first discovered in 2017. And Michelle, you said when you got the notification, it was potential interstellar object. Now, why were we expecting, like you said, Joe, we were expecting to see interstellar objects, but we hadn't prior to 2017. Why were we expecting to see interstellar objects?
Well, it's one of the things that goes into like what both Joe and I work on is trying to understand what's in our solar system and what that tells us about how it came to be. So when you make a planet, making a planet is a messy process. You start with just a disk, kind of a big flat round shape of gas and dust, and the sun starts. It ignites in the heart of that, and the material around that, some of it's feeding onto the star, and some of it ends up coalescing, like just clumping into little dust bunnies, like what you find under your sofa, right? That's how you want to think about how planets get going. And some of them combine, and some of them end up being planets, all the way up to Jupiter. You can imagine how many dust bunnies you have to throw together to get to Jupiter. But a lot of them don't end up in things. We end up with lots of asteroids. We end up with trillions of comets. And the process of being in, our sun doesn't just form by itself. It has siblings. It forms in a cluster of stars. And we see this happening all across the galaxy. This is how you get star clusters. If you go think pictures of the Orion Nebula or something like that, it's lots of stars hanging out together as they grow up. And so when that's happening, the stars are nudging each other. And that can disturb all of these little asteroids and comets around them. And they get kicked out. They go off. They go and wander in through the galaxy.
Right.
And so we're also in a place where you've got generations of stars going on, right? But our sun is not like the youngest star in our galaxy. There's been lots and lots of generations of stars before it. So those have all given their asteroids and comets to the galaxy. So we live in a place that's not just dark matter or gas or dust or stars. It's filled with flying rocks.
Right.
And sometimes someone comes to visit.
You have 100 billion stars in our galaxy, each kicking out potentially a trillion comets when they're formed. That's a lot of stuff flying around.
So some of our stuff might be flying to other solar systems.
Exactly.
Yep. We've been sending postcards.
Uh-oh, everybody put your name on everything in case we lose it. For anybody who's just joining us, this is Ask the Astronomers Live. And today we are talking about Oumuamua, our first known interstellar visitor. And so a lot of new, unique things. Although, I love the fact that this happened only in 2017. Like, do you think the pandemic meant that interstellar visitors stopped coming? It's like, oh, I'm not going to that solar system.
We had one turn up in 2019. So Interstellar 2, Borisov as it's known, it came right by then. And it was a comet. It had this beautiful, lovely tail. So astronomers all around the world, got to the telescopes and measured that and saw it for as long as we could. We saw that one for months, not just for days.
Yeah.
Oh, okay. Was it moving slower than Oumuamua?
It was moving much faster, but we caught it coming in. That's the difference.
Got it.
Yeah.
Got it.
So we're able to follow it for much longer.
Oh, excellent. All right. We have some questions from our audience. First one is from Steve Collins. Ooh, what is the current estimate of the number of detectable interstellar objects we can see each year?
Cool. Ooh, well, there's a couple of things that go into trying to figure this out. One is if you imagine things just coming past the sun has a bit of gravity, right? So it bends together some of the trajectories of the interstellar objects. So there are places you can look to see interstellar objects a little more easily than other places on the sky. So that goes into one of it. The other thing is if your interstellar object is more rocky, if it's like an asteroid, or if it's got more ice to it and it's more comety. So if something's more comety and it's smaller, it gives off this coma. It gets brighter. These ices all sublimate. So that's brighter and you can see it further out in the solar system. Rocks have to be closer if they're the same size or small to be visible. So Oumuamua, small, not giving off lots of gas, had to be close to us for us to see it. Borisov, comety, we could see it far out. So there's a lot that goes into making estimates of these numbers, but we have a big new survey coming up called the Vera Rubin Observatory, which will help us see a lot more of these.
Yeah. And so the previous estimates were somewhere once a decade, once every 20 years or 30 or more. With Vera Rubin, maybe once a year, maybe more. We don't know because there's only two. And so you don't know how to extrapolate from two yet. So it's an exciting new world.
That's amazing. And you've inspired me. I'm going to start a Comet E-Club. But there's a question. Oh, wait, no. Yes, we have one from Thomas. Wait, I have to make that a little bigger so I make sure I get Thomas's name correctly. Thomas is asking, what would be convincing evidence to the speakers to prove that Oumuamua was an alien artifact? If it had windows?
It could have said something.
Yeah.
Like we listened to it. We listened to it with a radio telescope, right?
We did.
It was very rock-like. Rocks don't
Yeah.
say things in the radio. Yeah.
Yeah. So that some sort of active thing like that. And we, there were searches for these kind of things. As Michelle said, we listened in the radio, we looked in the optical, we looked for flashing lights, we looked for thrusters. We didn't see anything. But as I mentioned before, we're not going to get any more data on this. So we'll never know. Really, truly, we'll never know about this specific object. Now, maybe in the next 100 years, we'll discover 100 more things just like a MOO-uh. And we'll say, okay, this was one of a population that we had not anticipated. And they're all rocks and we know how they're made. Or we never find anything like this again and it stays a question mark forever. We don't know.
Right.
That's the fun of science.
Well, that's the fun of real science as opposed to TV science, where everything is set and known and everyone knows everything.
I mean, this is one of sorry, if I could just follow up on that. This is one of the things, is right. Borisov turned up and it's a comet, but it's a weird comet. It's a comet that didn't form here. It's got what it's made of. Its chemistry is quite different. It's so rich in a material called carbon monoxide, right, which is a poison to us if you breathe it. But when it's ice at a comet like this, what it tells us is the star, the disk that this little comet formed in, somewhere else in the galaxy. It was making material in a way different from our comets. So you get this little piece of an alien star's planetary system, and it comes right to our doorstep. We can measure what's going on with these processes. And it's messy, and it's weird, and it's different, and we don't understand it all yet. And that's really exciting.
Exactly. We're learning. But we have a question from Babitha Titania Joyful. Well, I don't know if it's a question, but it's a comment. Shape. Why is it cigar-shaped? And please talk about the surface geology. Well, I'm guessing you may not have an answer as to why, but perhaps we have suppositions.
Well, to hold that kind of shape, either the cigar or the flat pancake, right? Either one of those shapes that fit the observations that we have, you need to have some sort of internal structure, some strength, right? If you just took a pile of sand, it would never hold that shape. And that's why we weren't expecting it. Most of the small bodies in our solar system are not coherent. They are piles of smaller materials. And so they just kind of fall into bally kind of shapes, maybe potato kind of shapes. So the cigar or the pancake implies that there's some sort of structure on the inside. As for the surface geology, we have no idea. So the artist concepts are artist concepts and are made to look cool, but we don't know. And we might not ever know.
Mm-hmm.
Right. So it's one of those things of were there craters or was it like if you try to think about what the surface geology is, it's also worth remembering that like the geology of asteroids, it's really different from what we think of Earth rocks, right? They're not like you can have things that are like a piece of comet. It can be as soft as the foam you get on the top of your latte. These things are not made of material in the way that you're familiar with if you walk outside and go stomp, stomp, stomp on the pavement. So what we can say about Oumuamua is that color of that surface, the way it reflects sunlight, it looks exactly like some of the small worlds we see out beyond Neptune. It's exactly the same color as them. That's the measurements we made with these big telescopes. That tells us that it's absolutely like that.
Okay. Wow, this is fascinating. Now, I'm going to interrupt the questions from the audience to ask one that I know we're all wondering, especially those of us who have to try to pronounce it. Oumuamua MOO-uh. Where did this name come from? How was the name of this object chosen? And then was it in a hurry? Because I know everything was happening very fast.
Right, yeah. So when this object was discovered, we hadn't had any rules for what to do about interstellar objects, right? There's committees on how to name a planet if you find it. Not that they've had much work lately. There's committees on how to name asteroids and rules about how to name comets, and this was a big question mark. And so while the International Astronomical Union was off discussing, like, what do we do about the name for this? The Minor Planet Center, which receives the data and has to give it some kind of designation, gave it its license plate, 2017 U1, and it went through a few iterations as we learned more about it. But that was never going to be enough, right? And so what finally happened was, because this object was discovered on Haleakala in Hawaii, it was the discoverers asked the organization MOO-uh MOO-uh, which is at the University of Hawaii Hilo in the Imiloa Astronomy Center, to help them come up with a name that would be appropriate for something so interesting and something so, just bizarre and new. And so they came up with a Hawaiian name for this object, MOO-uh MOO-uh. So the first half is something from afar coming towards you. The MOO-uh MOO-uh is very early. So in Hawaiian, if you repeat something like a huli huli chicken, huli means to turn. So huli huli chicken has been spun a bunch of times on the rotisserie. So MOO-uh MOO-uh is something that was very, very early, coming towards us to learn more about us, or to scout, or to discover. So this is the origin of this name was from this organization.
Oh, wow. Okay. Thank you. I've been dying to know that. And actually, I just want to take a second to say thank you to Lillian and Diane on Facebook for sharing their astronomy excitement. I mean, this is all very exciting, Joe, Michelle. Thank you guys so much. And thank you, Lily and Diane, for watching and for sharing. Now, I'd like to, before we wrap up the show, just ask you guys, do you have any final thoughts you'd like to share with the audience before we wrap up? Joe, Michelle?
Michelle?
Ooh, sure. I think this is, it's going to be an exciting time, eh? We've got Rubin Observatory starts giving us this full color movie of the whole southern sky with a huge big 8-meter telescope. So it's going to look really deep into the sky, which means we're going to get a picture of our solar system that's better than ever before. And that's going to let us discover a whole bunch more of these interstellar objects, maybe 10, maybe 100. It's going to be really fun to find out. And so that's right after it starts observing that we'll start seeing a bunch of these, kind of 2024, 2025, right? And we'll have the possibility of going to visit one of these, because we have missions that could potentially go and visit one. One of these is European Space Agency's Comet Interceptor. So that is a mission that can visit either a comet that's coming in from the edge of our solar system, a dynamically new one, or an interstellar object. And that's currently planned to go in 2028. So maybe Rubin Observatory will find the target for Comet Interceptor to go see. But these little worlds, they can come from a long way, right? Our Milky Way galaxy, it's a braid. It's this woven together set of stellar streams from all these other galaxies that fed into it. And okay, so galaxies are made of stars and they're made of dark matter, but they're also made of interstellar objects. So what's the chances that we have an interstellar object that started its life at a star in another galaxy that Rubin Observatory finds for us?
Can't wait. Joe, before we get to your final thoughts, we have one more question that I wanted to ask you guys. Let's see. This is from Michael Sullivan. And Michael wants to know, how do you track all of this? Is it possible that we miss a few of these objects if we're not constantly observing the sky? And was it missed coming in and only discovered on the way up? Okay, well, Michael, I mean, that's why we put Michelle in New Zealand. So while she's sleeping, Joe's awake, and they've got us covered. But no, that is a good question.
Yeah, no, absolutely. We certainly have missed these before. Given how, that we found two very close together, one in 2017, one in 2019, it's almost certain that others have come in the decades before when we weren't constantly scanning the sky with asteroid surveys and other astronomical surveys. And we will miss more again just because the sun gets in the way, right? Half the solar system is constantly unobservable because the sun is between us and it. And so, yeah, for sure, we're going to miss more. But as new surveys and new telescopes come online, we're going to expand our capability to find more of these objects and find them sooner, find them on the way in instead of the way out. And one of the ones I'm really excited for coming in the next decade is the NEO Surveyor mission. And so this is going to complement the Vera Rubin Observatory. So whereas Vera Rubin is an optical telescope, uses visible light, and it's on the ground, NEO Surveyor is going to be in space and use thermal infrared light. And so what it's going to do is watch the heat signatures, much like we do with NEOWISE, but on a bigger scale. And it's going to scan the sky every couple days, just like Vera Rubin does. And so between these two surveys, we're going to cover about 3/4 of our solar system regularly. And this will greatly improve our chances of finding the next Oumuamua and the next Borisov.
Oh, okay. Is Borisov the name of the one was found in 2019? The comet?
Yeah, that's the second one. 2I.
Interstellar.
Yeah.
Yes. And Joe, NEO Surveyor. What was that called?
Yeah, NEO Surveyor. It's the NASA's mission to put it's our next generation asteroid survey telescope. Yep.
Got it. Okay. Now, and as I said, I knew this topic was going to get people excited. We have one more question, so we can't go yet. This one is from Justin Bartel. Could Oumuamua and the lobes of Arakath have developed similar flattened shapes due to similar formation processes, despite the difference in their scales? And you're going to have to tell me what Justin is talking about with the lobes of Arakath. Do you know?
Arakath is the little world that the New Horizons mission flew past after it went past Pluto. So this is one of tens of thousands of small worlds that live out beyond Neptune in this kind of flat plane. They're called cold classical Kuiper belt objects, if you want to look it up in more detail. This little population, they're really interesting because they don't seem to have gone anywhere when the planets migrated. So they seem to be quite primordial, quite left over from how planetary formation happened. And Arakath, like, these photos are fantastic that New Horizons was able to make. It looks kind of like, I'd call it a pikelet. You guys might call it a biscuit, but I think that's also has some different meanings in the US as well. It's these two flattish disky things that are joined together. And that was a big surprise. It turns out that there's a bunch we didn't know about formation processes of how these dust bunnies grow into being, small worlds on the scale of a city to being on the scale of an island before they get up to that kind of continent scale that you think of something like Pluto. So there is a size difference here. Oumuamua, that's your skyscraper size, 100-ish meters. Arakath, that's 30 kilometers, right? You're going to have to do the miles for me. Sorry, Joe. But it's like that's multiple orders of magnitude. So there is potentially some different things going on in that size scale range. But it does imply there could be some things going on there about how planets get going. And so, and this is one of the really exciting things, is I wish resorting to aliens, while it's a fun idea, it's also the really easy idea, as opposed to that we don't understand things about how planets get made. That's really cool. It's messy. It's weird. There's so much to figure out. And we got the information coming right on our doorstep and from our spacecraft and from our telescopes that'll let us figure this out.
Right. And one of the things to remember about Oumuamua and Borisov too is their histories are totally different from anything in our solar system. They could be billions of years older or billions of years younger. Arakath has been out at the edge of our solar system for 4.5 billion years, getting impacted by some small things at very slow speeds. We don't know the history of Oumuamua. We don't know what it's run into, what it's seen, has it passed by other stars. And so even all the lessons we learn in our solar system have to be applied with care to these interstellar objects. And that's really what makes them so fascinating.
Right, right. Yes. So the process, based on anything we know about our solar system, couldn't necessarily be applied to Oumuamua. That's fascinating. But before we go, Joe, did you have any sort of things you want to plug or final thoughts to pass on to the folks before we go?
Yeah, I mean, I just want to say that, the next decade is going to be incredibly exciting for a range of small body science. With these new large surveys coming online, we're going to learn, everything we know now will expand by a factor of 10. And so we're going to know about 10 times as many asteroids, 10 times or 100 times as many comets, 10 times as many objects in the Kuiper Belt, and potentially 10 or 100 times as many interstellar objects. And so, the next 10 years really are going to be incredibly exciting for this, for this kind of science. And I'm really looking forward to it. Both Vera Rubin and NEO Surveyor combined are going to provide some really powerful data for help us understand how our solar system formed and our place in the universe.
Well, I hope you guys didn't have a lot of stuff planned for the next 10 years, because it sounds like you're both going to be busy.
Definitely.
This is what we love doing.
Oh, and we have a little note from Diane. It's not a question. It's just a compliment.
Thank
These
you,
people are interesting and so cool. Yes, they are. But we are pretty sure they're from our solar system.
Yes. As far as I know.
But no, thank you guys very much for sharing your energy, your expertise, and your enthusiasm. And I'm really excited about this and for learning to say Oumuamua. And for everybody out there in the audience, thank you for joining us as well. Now, the video of this show you can see along with many other videos over at universeunplugged.org. Or for those of you on Facebook, YouTube, you can probably just click on the link in the comments there. But make sure you subscribe to Universe Unplugged on YouTube or follow us on Facebook, because we're going to have more great guests like Michelle and Joe and more great topics like Oumuamua, pretty much every month. All right. Michelle, Joe, lovely meeting you. Great talking with you. And until next time, I'm Phil Lamar, and you have just asked the astronomers live. Thanks.
Thanks.